how many joints are there. So first joint, second joint, third joint, and fourth joint. So suppose you are asked to determine whether this truss, whether this uh, organization of member represents a perfect frame or deficient frame or redundant frame, then you can use the formula between n and j, and you can determine if n is less than 2j minus 3, then you will get deficient frame. If both are equal, then perfect frame. So that question you can also answer. But here we are not asked to calculate or determine whether this is a perfect or deficient or redundant frame, but we are asked to calculate magnitude and nature of forces in each members, and also the support reactions. Okay, so let's start. So first of all, what we'll do, we will draw free body diagram of whole system, not uh, a BD of joint or a BD of member. But the first step will be to draw a BD of whole system. So the external force, only one external force is acting on the truss, and it is acting on the point B. So let's apply the external force at the point B. It is 3 kilonewton, and at the point C, it is roller. So corresponding to roller support, you will get one vertical force. Let's name it VC. And this one is hinge joint. So at hinge joint, you will get two forces, one horizontal and another vertical. So it is your choice to assign it this direction or vertically downward direction to this VA. It is your choice. Why it is your choice? Because first time you are assigning these forces. So if you are assigning these forces first time, then you have liberty to take any direction. Good. Then how to determine these reaction forces? So to determine these reaction forces, we can apply horizontal force balance. So horizontal force balance. So take rightward direction positive. So 3 kilonewton is rightward directed. So we will take it positive. So 3 positive. Then HA is directed towards leftward. So opposite to this direction. So we will take minus sign for this one, minus HA. So it will give us HA is equal to 3. Then vertical force balance. So vertical force balance will give us VC. Let's take upward direction as positive. So VC is directed vertically upward. So we will take positive sign for this VC, minus VA. VA is downward directed. So minus sign. So VC is equal to VA. From this equation, we got VC is equal to VA. Now, next step is to balance moment about hinge support. So if you balance moment about hinge support, then you will get to see about this joint. We are calculating moments. So this 3 kilonewton will produce a clockwise moment, and its magnitude will be 3 into this arm length, 2 meter. So 3 into 2 meter will be the moment produced by this external force, 3 kilonewton. But this one is clockwise, so let's consider clockwise as negative. So 3 into 2 will be negative, and this VC is acting vertically upward, so it will produce a anti-clockwise moment. And what will be the magnitude? VC into perpendicular length. How much is the perpendicular length? It is 4 meter. So this will be your VC into 4 positive. So add these two forces. So algebraic summation will be VC into 4 minus 3 into 2 is equal to 0. So by solving these three equations, you will get HA is equal to 3 kilonewton, VC is equal to 1.5 kilonewton, and VA is equal to 1.5 kilonewton. So VA and VC are same. Then now we have calculated support reactions. So what are other forces we need to calculate or we need to determine? Other forces are forces acting on each member of this truss. So if you want to determine forces acting on each member, then you can apply method of joint. Method of joint. What this method of joint states, that you can draw a BD of each joint, and the equilibrium, or each joint will be in equilibrium. So draw a BD. Let's start with joint C. So ये है आपका final free body diagram. Three forces are acting at the joint C. Then what we'll do? We will again balance the forces acting horizontally and vertically on the joint C. So if you balance vertical, first start with horizontal force balance. So if you balance horizontal forces, then what you will get? This FCD will produce, its horizontal component will be how much? Horizontal component इसका हो जाएगा FCD cos 30 और this FCB इसका horizontal component कितना होगा? FCB का हो जाएगा FCB sin 45 degree. So only two forces are acting. One is FCD cos 30, another is FCB sin 45 degree. So this one is acting horizontally leftward, तो इसको हम लोग negative मान लेते हैं. This one is rightward, so let's take is positive. So minus FCD cos 30 plus FCB sin 45 degree is equal to 0. And then if you balance vertical forces by considering upward as positive, then what you will get? This 1.5 kilonewton is acting vertically upward, so let's take it positive. And this FCD, its vertical component will also act in upward direction, and its value will be FCD sin 30 degree. So plus FCD sin 30, and then FCB will produce downward force, vertically downward. So its component in vertical direction will be FCB cos 45. So यहाँ पे minus sign हो गया. And overall, the summation of algebraic summation of all forces will be 0. So if you solve these two simultaneous equations, you will get the value of FCD and FCB. So the FBD of joint D will take this form where this force is acting along the link CD. So FCD, this one is FCD. We have already calculated the value of FCD in our previous slide. So at the point D, its direction must be opposite to this direction. So at the point D, you will get FCD as theta. So next force along the member DB. So first time we are assigning this force FDB, so we are free to take vertically upward direction or vertically downward direction. There is no problem. Then FDA, I am considering this force in this direction. Then force balance. If you balance the horizontal forces, you will get minus the component of this FDA horizontally will be equal to FDA cos 30. Then this 4.10 kilonewton, its horizontal component will be 4.10 cos 30, and it will be positive. And if you solve this equation, you will get FDA is equal to 4.10 kilonewton. Then balance the vertical forces, you will get FDB vertically upward. तो vertically upward को हम लोग ले रहे हैं positive. So ये हो गया आपका positive. Then minus 2 into 4.10 sin 30. So if you solve this equation, you will get FDB is equal to 4.10 kilonewton. Okay. So we have calculated force along this member, this member, this member, this member. Only one member is left, that is this member AB. So now if you draw a BD of point A or point B, then you can easily find out the force acting on the member AB. Next concept is the concept of zero force members. So if you solve a problem of truss, then sometime you will find that some members of the truss, okay, are bearing zero force. Okay, that means in some member of the truss, you will find the magnitude equal to 0. If you find any such member having zero force, then those members will be termed or will be called as zero force member. Okay, so how to find that which member of this truss is carrying zero force? Okay, so what we can do, there are some shortcuts, so you can directly use those shortcuts and you can easily identify the zero force members. But if you go by procedure, then first of all you will need to draw FBD of different joints. So suppose I'm starting with joint A, and the FBD of joint A will be of this form, where FAB is acting along AB and FAF is acting along AF. So if you balance the forces, then you will find that FAB is 0 and FAF is 0. तो ये जो FAB होगा ये जीरो है, that means AB force is a zero force member, and AF, the force along AF link is zero, so you can say that this AF link is also a zero force member. Next, if you draw a BD of point D, then what you will get? There will be a force acting along link DE, so let's name it FDE. These forces are acting like this. If you balance these forces, then you will find that FDE is equal to 0, FCD is equal to 0. Why these forces are 0? Because the net force corresponding to these forces will be acting like this. And if there is any unbalanced force, then what will happen? The whole system will not be in equilibrium. The equilibrium will be disturbed. So just to avoid that disturbance of equilibrium, we put FAB is equal to 0 and FAF is equal to 0. So once you determined that these members are zero force members, then in the analysis of your truss, you can remove these four members, and your analysis will become simple. Then there are some shortcuts. The first shortcut is that if only one force is acting at a joint, then you can directly write FAD is equal to 0. No need to balance horizontal or vertical forces. Similarly, if two forces are acting at a point and they are not acting in a they are not acting along a straight line, then also you can put these two forces equal to 0. You can make them 0, no problem. So here you can see these P force and Q force, they are not acting along a straight line, so P will be equal to 0 and Q will be equal to 0. Then suppose three forces are acting at a point and two out of three are acting along a straight line, then we will get P is equal to Q, but the value of R force will be equal to 0. R will be 0. So in this, if you use these shortcuts, then directly you can determine which members are zero force members.